So you're not quite sure what binary is. Don't worry, you will soon. First, let's check that you know how to count. 1, 2, 3, 4, 5, 6, 7, etc. Now, if I've lost you, this might not be the video for you. If you're still with me though, I want you to think back to that weird time in your life where you learned Roman numerals. Recall how they instead counted with I, I, IV, V, VI, etc. That was just a different way to count, right? A binary is just another new way to count, just like Roman numerals were. And this is how we count in binary. 0, 1, 1 0, 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. Now, I don't blame you if you're starting to get confused. Firstly, let's stop looking at them like 10 and 100, because that is completely wrong. It's 1 0 and 1 0 0. But why? Well, how about we stop saying 1 and 0, but instead say line and circle? So, therefore, in binary, we count like this: circle, line, line circle, line line, line circle circle. And look, I understand if this is confusing, but don't worry, we'll clear it up soon. Now, if you're used to what I would call base 10, or what is called base 10, once we get through all 10 possible symbols, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we simply throw a new number to the left, reusing the same symbols, starting at 1 and resetting all the other numbers to 0, like this. Now, binary does the same thing, but because we only have two symbols to work with, line and circle, we have to throw on a new number much sooner than when we count with 0 to 9. Let's just count to 12 in binary so we can see exactly what it looks like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's compare base 10, Roman numerals, and binary when counting to 5, so you can just compare the differences. Alright? Now hopefully now you understand that binary is just a different way to count. But the binary counting system is still confusing, right? Because I bet if I said, write 10,000 in numerals, so base 10, you would do it easy peasy. But if I asked you to write 10,000 in binary, the only way that you might think to do that is by writing out each number until you reach the 10,000th binary number. And that's only if you've picked up on the pattern so far, which is still quite confusing. And that would be ridiculous, I know. But don't worry, there's a much simpler way to do it, and it looks like this. See, the first option we have is line or circle. Next, we add a new digit, a binary digit, also known as bit for short. And the magical part of counting in binary is that each bit, binary digit, is worth double the previous bit. Have a look. Remember, this was 1, 2, 4, and 8 when we counted before. See how each line, or 1, moves across once every time we double the previous number. Now this continues on forever in binary. So we can actually write any large number by putting down this cheat sheet for each bit. For example, to write 4096, we just put a line here followed by all circles. Or for 32,768, we put a line here followed by all circles. Now if you're miraculously still following this explanation and you're particularly switched on, you might be thinking, yeah, that's great, but what about something like 4,000, which doesn't perfectly align with one of those numbers? Well, with binary, we add the value of each line, or one, to get a final number. So that's why 7 looks like this. It's because we can't put the line here, since that's 8. So we put a line here, which is 4, and then a line here for 2. But then when we add those together, we're still only at 6. So then we add a line here as well, so that we get to 7. This is because 4 plus 2 plus 1 equals 7. Or to count to 10, we would do this. Find the closest number to 10. 8 plus 4 is more than 10, so it's a 0. 8 plus 2 is 10, so we put a 1. And then the last number stays as 0. Because 8 plus 0 plus 2 plus 0 gives us 10. I'm pretty sure you're starting to get it now. But just to make sure, let's drive it home with a couple more examples. So let's go with 52. Now the closest number is 64, but it's too much. If I put a line in the 64 column, we're already at 64, which is too much. So I know I have to put a line in 32. After 32, I then consider the next number, 16. 32 plus 16 gives us 48. That is still not enough, so that's good. I put another line in that column. Now, I have 48 in total, plus 8 would give me 56. That's too much. That's more than 52. So I know to put a circle or a 0 in that column and move on to the next number. 4. So 48 plus 4 is 52, exactly. So I put a line in that column because that is what I want, and now I know that all the numbers after it must be zeros because I'm already at the number that I wanted to achieve. So 52 would be line, line, circle, circle, or 1, 1, 0, 1, 0, 0. Okay, what about 12? Well, we're not going to do 16 because that's too much. So we'll start at 8. What's the next number? 4. 8 plus 4 is 12. So I immediately know that it's 1, 1, 0, 0 to get to 12. Alright, and let's just do one last example. Let's go with 127. Alright, so 127, I can't put a line in the final column because 128 is too much. So I go to the next one, 64. So I put a line in 64. 64 plus 32. Is that enough? No, not enough. Okay, plus 16, still not enough. Plus 8, still not enough. What about plus 4? Almost, but we're not quite there still. Plus 2, nope. Plus 1, yes. We are now at 127. Now there's a lot more detail that we could go into. I could start to explain the difference between 8-bit and 64-bit, or 32-bit, 64-bit, how they relate to IP addresses, or processing architecture, the different types of operating systems, whether they're 32-bit or 64-bit operating systems, and how all that ties into binary. But I believe that's just going to be too much for the scope of this video. This video is just to understand what binary is. It's in these later topics like IP addressing, subnetting, or even compute architecture, where you can start to actually apply this basic foundational understanding of binary so that you can properly understand all of those other topics later on. So from here, I think we will call it. I'll thank you for making it this far in the video and really appreciate any support that you can provide. Hopefully, I will see you in a later video. Thanks for watching.